All right. Yeah, welcome everyone to this, the latest Zero Carbon Mine webinar, where we just really focus on, sharing information and collaboration around the decarbonising the mining industry. Today we've got Michael Short from EcoHoist, who's going to talk about their hoisting system and give a bit of a preso. And if you've got any questions, you can save them then. But if there's anything that comes up during the preso, then raise it. So I'll hand it over to Mike and go from there.
Thanks, Brett. So just in the chat for anyone that's on the call at the moment, I've just put the link to the website and the video, which you're welcome to refer to after the presentation. And then I've also got a link there to the case study, which we'll be releasing soon, which will delve into the further applications of EcoHoist and does a short comparison between an EcoHoist operation and a haulage operation. I'll touch on that as well in the presentation. You able to see the presentation slide?
Yep, that's all good.
Oh, fantastic. So hi, I'm Michael from EcoHoist, and I'm the business development engineer. EcoHoist is a new solution, and part of our team is driven to help decarbonise underground mines. And in that, it is by providing a commercially compelling alternative to replacing diesel haul trucks and helping decarbonise operations in that measure. So I guess the first question is what is EcoHoist? We've been considered a cross and a bit of a hybrid between traditional skip hoist systems and also vertical conveyors. We use a chain system that acts as a continuous vertical bucket elevator system. And the largest value proposition for EcoHoist is, rather than using the one larger shaft, which is a very high capex exercise for projects, we use two smaller shafts for the system, which really reduces the overall capex and actually enables us to use a raise bore method for mining these shafts rather than your blind sink or traditional shaft driving excavations. Sometimes we've been referred to as the low-cost skip hoist. Like I said, we're not actually a skip hoist system. We're more of a vertical bucket elevator, but we have been referred to as low-cost skip hoisting. So how the system works, I'll just take you through the material path flow of the system. So initially, the material will need to be crushed. So we'll require preliminary crushing, and that breaks the material down to a 40 millimeter size maximum. This is then loaded into our chute, which is designed to maximize ore flow whilst minimize bucket wear as the buckets move up through the chute. We then have, once it's loaded into the chute, it comes down into the buckets, and the buckets take it up to the surface. In the underground features of EcoHoist, we use sprockets, and also which are used to guide the vertical bucket elevator, as well as put tension onto the system for when the system's loaded and unloaded. There will be slack in the system, and that takes out vibrations and the slack in the system itself. So passing up through the shafts, we have one side which will be hoisting material to the surface, whilst on the other shaft there'll be buckets coming down back to be loaded. So we'll have two shafts which are diameter between 1 to 1.5, depending on the tonnage output that we will require. A key point about these shafts is these have to be very vertical. They have to be vertical in the sense that these are fully suspended loads, so they're nice and straight, which we can achieve with Micon's directional drilling system that they have in place. And in terms of how much material is suspended in that shaft, is actually less than a skip hoist system, which can be 80 to 100 tons. These systems suspended in the cable, the skip itself, as well as the material. We use a lightweight material that has high strength in the chain-like structure, which and because we have less material suspended throughout the entire shaft, we only have a suspended load of 30 to 50 tons itself. Something I didn't touch on before, but please ask questions throughout rather than me just go through the slides. If there's a question come up, Brett, please just pause and we can go through that question at time, if that works.
Yep, sure.
Yeah, still able to see the screen. So how to and then so once the material reaches the surface, we unload in a sprocket-like mechanism, and that is very similar to bucket excavators loading mechanisms with the large bucket wheels. And so the material shoots down and then goes into a conveyor belt system. And so the key component of the mechanical chain itself, which is driven around this sprocket, like I said before, is made up of a really strong, lightweight material in a chain-like mechanism, and then it's shielded with plates, and the buckets are attached to the plates. This high strength and lightweight allows us to hoist up to depths of 1,500 meters, and the continuous flow and nature of the system itself allows us to have production rates up to 2 million tonnes per annum. So EcoHoist, we drive the value proposition of having more tonnes for less, and explain a little bit on the more tonne side, and these are the benefits that EcoHoist brings, and the savings in terms of costs, and then also the savings in terms of emissions and how it will make operations safer. So like I touched on before, we actually reduced the shaft diameter compared to traditional skip hoisting. That's actually 6 times, up to 6 times we reduced the shaft diameter, which is a massive cost savings. The head frame itself is actually 5 times smaller. We're not requiring that large pull that skip hoist systems because we have the sprocket design. It's a much shorter system. And we also, in an electrical component sense, have further cost savings there in comparison to a skip hoist. Skip hoist systems require really high accelerations, really fast accelerations and high velocities in their system because they need to get that quick cycle time, whereas we're just a slow, continuous moving system. We actually can have much smaller components. So for example, a 1 megaton operation, they might have a 3 to 5 megawatt drive system, where we're more looking at the 400 to 500 kilowatt system. So we'll see further cost savings in a production sense also in comparison to haulage trucks. There'll be far less, we'll reduce the distance that's actually required in the operation itself from trucking to surface. This optimizes the production cycle itself and allows us to reduce the number of trucks underground. That has the flow-on effect of reducing the number of required operators, and also the actual ventilation itself will see dramatically dramatic reduction in the ventilation required. Keep in mind the ventilation system is actually a cubic relationship. So if we have 10 trucks compared to 2, it's rather than a linear relationship, it's more of a cubic relationship. So we'll see some massive cost savings by reducing the trucks. Removing the fleet out of the underground operation will also create a safer environment, having less interactions between fleets, between the diesel fleet and other equipment, maybe less personnel underground, and then also in a sense of the shaft itself. Skip hoist systems require personnel to inspect these shafts weekly, usually on a weekly or fortnightly occurrence. Because of the size of our shaft, we physically cannot put a personnel down the hole. However, because it's small nature, we can get far better reading using remote operations and cameras and sensors. So because of the confined nature, we can get better readings of the integrity of the shaft itself remotely. Any questions come through so far?
Not as yet.
Oh, keep going. And then in the sense of EcoHoist removing the diesel fleet comparison, we will see far less emissions created in the operation itself, and savings from less diesel, but also the less ventilation. And then in comparison to the traditional skip hoist system, because we have those smaller motors, will have a little less peak power draw and demand on the system, so it'll be more efficient energy consumption. We just have a question from Don. Says in referring to going back to the buckets and describing them in a bit more detail, particularly the size. Yeah, definitely can. So we'll go back to the buckets. So yeah, to give a bit of an overview on the buckets itself, these consist of a chain system, which is it's a strong uses modern day composites such as fiberglass to have a really strong lightweight material, which is shielded with a plate, and then the buckets itself are attached to plate. In terms of pitch, or the distance between each link, they range from 1 to 1.5 meters, probably more than 1.2 actually. And then in terms of the diameter itself, we're looking at 60 to 80 centimeters diameter, and that'll be just a round bucket, so 60 to 80 centimeters wide. So we see EcoHoist being used for a range of applications. So mines that are interested in increasing their production rate, they're deeper than 250 meters. They're looking for those cost-saving opportunities and opportunities to reduce their carbon dioxide emissions, the diesel consumption, and actually really accelerate the electrification of their operation.
Got a couple more questions that have just come through there, Michael.
Oh yeah.
One around the top size of the material. Was that, you said, was it 40 mil?
Oh, I guess I see the questions there. Yep. So the top size of the material is, we're looking at 40 millimeters as a test. This is an early stage technology that we're developing. We do want to push that bar, but we started with the 40 millimeter top size currently.
That one was just around cases where it's been implemented, and yeah, I take it that's still a work in progress, but
yeah, so we're an early stage technology. I will touch a bit on it in the later stages of later stages of this slide pack of the progression plan to implement that first product of a full scale demonstration. In terms of duration, we're aiming to have one of these installed by 2028, really pushing on that 2030 goal for mining operations to have a commercialized solution to deploy before then. So in a commercial comparison sense, we've made a quick cost comparison between haulage trucks and skip hoist systems. Because of that much lower shaft capex, we greatly reduced the overall capex of the operation, and the low opex of the system compared to haulage trucks, we actually will see an overall lifetime cost savings in the material transport to surface. So taking the benefit of haulage trucks with a low capex, but then also taking the benefit of skip hoists with a low opex and combining those. So to give us a sense of where it sits in comparisons to with other technologies, is we see EcoHoist ranging from that 500,000 tonnes to 2 million tonnes per annum and down to depths of 1,500 metres. EcoHoist plans to be modular type system, so operations that are looking to have production rates greater than 2 million tonnes per annum, which there will be a lot. We see it being commercially compelling option to have multiple of these EcoHoist systems throughout the mine, which then unlocks opportunity to have more dynamic mine design plans, but still have the benefit of skip hoist systems. Do we have any?
Yeah, a couple more.
Question from Ben Brown. Dust is something we've started to look into. We would imagine similar to most of the operations with, I guess, critical infrastructure for it to be in the return air rise system, similar to fuel bays and other crushing compartments. Similar management style to crushing underground, however. So that's how we're looking at those metrics, but pretty common to manage dust undergrounds. So we think that will be a easy problem to solve with the available technologies.
And there was another one around 2028. Is that due to the low TRL of the system, or the interest from clients?
So we have got interest so far. Currently, we've got 2 letters of interest from mining companies, and we're working on a third. We're also working with a party in capturing their membership base that are currently interested in developing this technology. So we have some pretty interesting conversations ongoing at the moment. In terms of TRL, we're sitting around that 4 to 5 mark. We've got a pretty robust plan ahead to meet that 2028. So in terms of installation of the system, like I said, we can use raised bore systems, so that will be a big benefit in deploying many of these systems. A much faster method to build a shaft rather than blind sinking. Then utilising the Mycon's RVDS product to get the straightness. We've actually also included liners in our whole systems, in our cost systems for these for an EcoHoist system, and that depending on geotechnical stability, either steel shotcrete or a hard polymer plastic. And then in terms of underground, pretty generic drill and blast underground. And then in terms of the footprint on surface, think of your medium to large warehouse or daily shed that's used on the mine site as to fully encapsulate the EcoHoist system. Little bit bigger than a skip hoist motor room, but not bigger than the hoist head frame itself. And then in terms of transportation, we see EcoHoist being, because of its small size, we can ship these out in shipping containers and install them on site. To touch on maintenance, there will be a range of parts, but they're compared to a a truck, for instance, there will be far less amount of parts in the system itself. Really, we're looking at lots of parts, but only very few variety. So buckets, chain, shield plates, and pins, and then a sprocket at the surface and a sprocket at the bottom are the real key components. There will be wear throughout the buckets, which is a common question, is how we manage the wear. We see the buckets being interchangeable, so pretty easily to clip off and clip back on again with a new part. And we manage that through our loading mechanism at the bottom of the wear rates. Pins and rollers, there'll also be wear throughout those. But we're looking to build a 30% demonstration unit, which is kind of your car park test bed, which will give us much better insight to those. In terms of the drive system and your power components, we are partnered with ABB. There is the actual design of the EcoHoist system itself is from a drive and powering components aspect is exactly the same as a skip hoist system. We just remove the barrel and put on the sprocket. So think of in terms of calculating the power components, we're very similar to our friction hoist system because we have the balanced weight on each side.
Got a few more questions that have come through there.
Yeah, I imagine that would be.
I think the last one was probably Michael, was like about retrofitting it into an existing shaft, maybe even larger diameter. I suppose it's, I don't know if you've looked at that as yet, but
yeah, that's an actually interesting one, and something I'm pretty excited for is once we prove this system or EcoHoist works is asking the question, all right, we already have these existing shafts. If we can put in, say, there's a 2 million tonne per annum shaft, which is still 5 meters wide shaft, can we pair 2 EcoHoist systems in the one shaft and double that production? I think that will be the point where EcoHoist is really starting to be to take over that skip hoist market and actually allow mine sites to capitalize on their already invested assets, such as a big shaft. So it's definitely something we're looking forward into, and we have done some designs on that. For to try, so a question from Dalmon, what do you think the ideal site would look like to try this in, and which sort of existing mine would you find suitable to do a pilot? So for pilot size, in terms of a first ideal site, we're looking at those operations which are trucking and haulage constrained, whether it's a ventilation constraint or a depth constraint, which sometimes they are paired. So looking at those operations that want to increase their production, but they can't due to their haulage fleet constraints, or a site that's looking, and then or a site looking to decarbonize, which is a big aspect of removing their trucks if they want to electrify, and a big outcome and a consistent message through the Electric Mine Consortium that was at Perth is the understanding of using battery electric trucks to actually haul to surface is it's not an easy challenge or problem to solve as we thought it was going to be. And yeah, please refer to the IGO case study which was released. That's really interesting too. I'm looking at that. So ideal first site, someone that's getting constraints from ventilation, trucking, or also looking to electrify. In terms of depth, what that would look like, that 500 to 800 meter depth would be a great first full-scale pilot trial. There are steps that we'll take before that to getting to that point, though. And then in terms of Gary's question, is the backfilling and paste in dry stack tailings. That's an interesting concept that I didn't actually put in this slide deck, but it is something that we have looked into. So if I go back to this one here. So with these bucket designs, what Gary's asked about is we have looked into a backfilling option. I figured this is the first introductory slide, so there's only so much information that we can tell. However, the question came up on opportunities to use this as a backfilling system. So we have designed an EcoHoist system which flips the bucket in a sense that will have buckets which can hoist material up, and then once it goes over to the other side, it can also take material down the surface. And this unlocks a lot of opportunity for using dry backfilling dry stack tails, legacy waste that's on surface, as well as other material that wants to be taken underground. It actually creates a balanced system. So thanks for that question. Is that all? I think, all right. Go back to the start. So I guess this is touching on some of the more common questions of like, what are the big risks? This is a new tech. We know there's going to be some big challenges with this tech. However, there's going to be some great rewards also. These are some of the key questions, and one of the big ones is what happens if it splits? So we've looked into the failure load and looked at, all right, what happens if it fails due to structural load or a cyclic fatigue, or the system actually completely snaps in the middle, and what does it do? What does the system do, and how does it react? We've done early stage designs. We have done some computational modeling on this. And from the physical demonstration, it actually kind of jaggers itself. So we did a small jagged test. It's a small split test where we did 50 trials of snapping it in different places to get an early stage understanding, and that actually kind of jammed its whole set, jammed the entire chain link itself, which then the recovery process was more of using a grapply type effect or lowering it down controllably with grippers. This is something we want to develop further in our test bed and our warehouse demonstration, but this is definitely a risk that we're looking at pretty seriously. Rock spillage. So like all shafts, there's not a fully enclosed system. How do we control the spillage and loading, and also mid-shaft spillage? So we've looked at fully computational modeling with a partner in loading the actual mechanism, looking at different variations of the mechanism to minimize the spillage. There will be an apron feed underneath to just relay the material, but we're still looking at 90% of the material to actually go into the bucket that's loaded. In terms of mid-shaft spillage, if a material was to fall off the bucket in the middle of the shaft, we've looked at the design constraints, which is very similar to industry standard clearances between gaps, and that's just 2.5 times the particle size max, and also limiting those buckets themselves to an 80% fill factor that we'll use cameras and scanners to make sure we're measuring that load right. Jamming, that's another big question that we often get, is what happens if the system jams in the middle of the shaft? So jamming's likely to be an event which will occur before a snap. So we'll have sensors throughout the entire system to pick up the jam, and then it won't snap. And the causations from that is jam between the material itself of overloading. So we can manage that by underloading the system and having reducing the chances of that occurring by managing the load rate of the material. And then also the other question is what happens if something that goes into the system which shouldn't, such as a tramp, think of an iron bolt or a piece of get, whether that enters the system. And so similar to your conveyor belts and shaft systems, we'd have that detramping mechanism at the start of the large magnet to really remove all that material. If it does go into the system itself, we'll have, the design is to currently have a more confined shaft for it to go through before it enters the main shaft. And that confined shaft will have really accessible areas that if there any jam occurs, it will occur in that spot, and we can clear it. The other question is geotechnical stability. Big shafts in skip hoists, they're well known for self-caving on themselves during development or even during its life. They're also known to require a fair bit of structural integrity around the sides to actually hold those shafts, together and make them geotechnically stable. Our cost modelling has included all the way through to completely steel lining the system itself. That would be limited to suspended weight. However, we're still not even touching the loads which are required in skip hoist shaft lining. So we've looked at steel, shotcrete, or plastics to line the entire shaft itself, and that will create a far more geotechnically stable system in compared to a large 6 to 7 meter wide shaft itself. So in terms of research and development, we've been through a series of detailed design of the system. We've completed a lot of accelerated testing on the links itself. So this is tensile testing of how do we go until we split. We're getting some pretty incredible results, as well as the cyclic loading. So we exposed it to, as the system would go around the whole system itself, would be exposed to different strains, which means the chain link itself will actually stretch and compress throughout the entire cycle. And we managed to get 20 years of cyclic loading on these systems, on these links, before we actually ran out of time. So we still got to go back and further test, but it was pretty promising and gave us really good data on what these chain link systems can actually achieve. We've made a small scale testing that simulated the loading of material as well as unloading. We've built one-to-one demos, which some people may have seen before at conferences. And then we've also looked into some wear testing and done some computational modeling, which is becoming quite interesting for designs. So this is the 30% demonstration unit, or the warehouse demonstration unit that I've been referring to. This is the next step for EcoHoist, and this creates that research and development test bed that we can work with our OEMs that will be supplying these components. We can work with mining operations to answer the questions of what is going to be the downtime, what will be the availability, can we achieve the availabilities that we require, what happens if it links, how long will it take to recover. Really give us a good insights to that 30% demonstration before we go to that next step. And this will also give us better understanding to help with creating because this is a new tech, to give the regulatories understanding of how this new technology works, and make sure we're ensuring a safe and reliable system to be deployed into sites. So it's worth mentioning that this 30% scale demonstration is we're actually working in a joint partnership with ABB on. And so the system's designed to be fully ABB spec'd to their safety and use ABB's risk management procedures on. So recently completed a case study. This was more of a generic mine that we can look at a 500 meter deep production rate. So this is like an ideal first customer at a production rate of 1 million tons, and we compared what does it look like with their diesel haulage option compared to if they installed an EcoHoist system. And so we looked at this case study, and this was reviewed by ABB and Mining One, which is You can go to our website and see you can see a section that you can fill in. I've put the link at the top, and this will allow, and then we can send you through the case studies for your review as well. So we actually saw EcoHoist provide an increase in the MPV. We saw a reduced total diesel truck. So the number of diesel trucks were reduced. The overall carbon, the carbon released by the operation was reduced by over 100 kilotons. We saw a 250 kiloton increase in production as well. We assessed that case, and we also saw an investment IRR of over 200%. With those learnings from the case study, we actually applied it to integrations, an early stage integration desktop study. And this looked at a ASX listed mine company that were looking at their brownfield operation, and they were currently under a scenario where they were actually ventilation constrained, and they'd have to do an entire new shaft if they wanted to achieve the production rates they wanted. So rather than, in comparison to that, we actually looked at what it would look like if we were to install an EcoHoist system, and we actually saw a reduction in the overall lifetime cost of 18 million. We saw them reduce their truck fleet by 4, and that was a result of reducing the overall TKMs required by 6 million tonnes. We saw nearly 30,000 tonnes of CO2 reduced, and then we also looked at the potential opportunity to increase their production rate, because now they're not constrained by their ventilation requirement in their haulage fleet. We could actually increase their production, and that would result in increased revenues. The next steps for us is the 30% demonstration. So we're looking to do that by 2024, the end of this year. And then we're looking to deploy that first customer full scale at that 0.5 to 1 MTPA, around the 100 or 200 tons per hour, and that is to be starting in 2026, and then aiming to have that fully commercialized product ready for 2027, and then deploying those commercialized projects in 2028, like I said before. So yeah, thanks for listening, and that's just a little bit about EcoHoist.
All right. Do we have any more questions out there? I think seeing what just came up.
Got a few.
Have one around the rough capital cost on a first customer deployment.
Which one was? Where's that?
In the Q&A.
Oh, Q&A. Just can't find it. Oh, the rough capital cost first customer. Yeah, so we didn't touch on the capital cost as such, but for these systems, we'd be looking at the 20 for a first customer at a 1 million ton per annum. So for that, for the integration study that we completed, which was on a mine site that was 1.3 million ton per annum, at about 600-700 meters deep. The cost for that project overall was 40 to 50 million. And that includes your full shaft installation, your crushing underground. These numbers came directly from OEMs and or shaft installers. I think there's a question as well on that I missed on, could we potentially just add EcoHoist to the system with the transfer stations? Absolutely. So we see EcoHoist getting to the 1500 meter mark, and that's where the technology starts to reduce its tonnage capacity because of the amount, or because of the weight itself, essentially. But then having that transfer station and linking them down like the daisy chain like system, absolutely achievable. We want EcoHoist to be seen as a modular system, not like a centralized skip hoist system. So think of a mine site of 6 million tonnes that has 3 of these systems in different parts of the operation.
Probably quicker and simpler to deploy than a big shaft, so you can have them strategically placed.
Yeah, we were having a good chat with a potential customer about a block cave application actually yesterday, and it was just the thought process of, all right, we have a block cave and we've got to have a crushing, but then we're restricted to a shaft or a full decline for conveyor. It's what happens if a block cave can have 4 of these points on each side, and then what does the production rate look like from these systems now?
Any more questions out there? Let's getting close to the end, I think. Yeah, it's a good point from Don around like sort of reducing your risk. Like if you've got multiple hoists, one goes down, then you've sort of got back up. Definitely.
Yeah, absolutely. And then also in terms of like availability too, if you have a skip hoist system go down, your whole mine's cut off from production. If you've got 3 EcoHoist systems and one goes down, you've still got that 66% production rate.
I suppose like you're talking about doing the maintenance easier to do scans of the shaft and whatever. Like,
yeah,
how much downtime would there need to be to sort of regularly do those sort of checks on the system and the shaft and whatnot?
Yeah, that's something we're looking to answer and get a far better answer in the warehouse demonstration model. But we're looking to have more of a continuous analysis and use a preventative maintenance approach. So we're working with a few companies on how we'll implement that. That's to have that stem in terms of like a full downtime where because of the system being far smaller items, we see it being more of a quicker continuous rather than having to shut the entire system down, maybe 2 shifts in total to have a full big maintenance schedule.
It's probably a lot quicker and easier than a bigger shaft or whatnot. All right. I think that's probably just about the end of any of the questions, but unless there's anything else, last minute questions from anyone, I think we'll probably call it there. But no, thank you, Michael, for running us through that. It's interesting technology, and definitely it'd be interesting to see how it plays out, when it gets out there on sites around the countryside. That trial, your next step, your 30%, where are you looking at doing that?
We're looking at doing it in Adelaide. We have had some conversations at doing it in some other capital cities, but I'll be sure to post an invite and we'll definitely do an opener. And I think there'll be an event there for sure.
No worries. Sounds good. I just saw something in the Q&A.
Okay.
There's a question from Hugh. Given that it's a fully enclosed shaft, can you do sub-vertical shafts?
Sub-vertical shafts, as in shafts that aren't completely vertical.
Yeah.
Part of the I guess the energy efficiency aspect is the system being dead vertical. That allows us to reduce friction within the system and actually maximize the strength of the system itself. So we haven't looked at the sub-vertical nature yet, and I haven't looked at the sub-vertical nature, but it's more direct vertical.
Yeah. Might be like once get the vertical sorted, and it might be an opportunity down the track.
Yeah, absolutely.
Oh well. Like I said, might call it there, but no, thank you again, and good luck with it.
Yeah, thank you all.
Thanks, all the great questions, everyone.